Okay, everyone got something else? No? Okay, you don't need your computers out. What's your screen, please? I'd like to see your pretty files. Please in the back. Thank you. And you need something to write with, of course. You probably won't need a calculator today. But we're gonna start off with, on the front, there's several rules that are right at the beginning. And right at the beginning, we're gonna chat about what those rules are. So we talked about the derivative of all the sine functions, and now we're gonna do the derivative of all the logarithms. We're gonna start out with logarithm of base A of u. Okay, so if you're asked to find the derivative of a logarithm, you have to identify what this little piece right here is. And the derivative of it is u prime over u, derivative over original. And then on the bottom, you like chain on an ln a, where a is this little base number. So try to get that in your memory now. If you can, it is on the rules quiz Friday. So log base a of u goes to u prime over u ln a. Or it also works if this is an absolute value. It's the same u prime over u ln a, same rule. And that's because for logarithms, you can't plug in anything that's negative anyway. So this absolute value is implied in every logarithm anyway, because your domain can only be logarithm of a positive number. Question?
If it's negative, we're just not.
Correct. So if you plug in a negative number in, excellent question. So if you were doing like negative blah, 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 you're going to plug it in. It's a logarithm. You're going to say it does not exist. Done. Doesn't. Good question. Okay, then look at this one below. Do we remember the base of this one? E. Yes, good. Okay, so ln is just log base e. We left an implied e. So when you do this one and you find this, you do u prime over u. There's an implied ln e right here. Oh, it should be. Okay, I'm not used to her board, so give me a second. Eraser. Let's do this. Sorry. All right. So where the ln is, there's like an implied ln e right here. But ln of e is 1. And so that rule seems like it's a little bit shorter because it is, because the log is base e. And so if I had an e right here, where I'm putting like this a is log a, I've got the e, so I put ln e there, but ln of e is 1. And so that rule feels like it's a little shorter, it's just u prime over u. That's kind of 3 different rules, but we're mostly going to focus on that, kind of seeming like the same thing, and then this one, just u prime over u. Okay, let's try it. So we're going to start out super simple. So first one is base e, so that's the shorter rule. And this right here is my u. And so in my head, I'm thinking, I know I have to do u prime over u. Derivative over original. Okay, so help me out. What's u prime in that case? 2. Very good. You got one person listen. Awesome. Everyone else is just already done probably. Right? So u prime over u, 2 over 2x plus 1. Now, technically, there's an implied ln e on the bottom, but I don't write it because ln of e is just 1. Okay. Second one. All right, let me figure out. I'm not used to using smart. How do I get to? Is it not get to the next page? Just this forward button will go to it. Thank you. Thank you. Okay, then second problem is a little bit longer. We're just going to leave that there. My board just works over. Okay, we're just going to leave that there. We'll deal with it. Okay, so second problem has 2 things that make this a little bit longer. First of all, there's a 2 on the bottom. That means when I do my u prime over u, I'm also going to put ln 2 on the bottom. Secondly, if you can expand first, put yourself a little note. Expand first makes the problem shorter. And expanding, we haven't talked about in a while, but is when you take anything that's inside this part and you can break it apart. There's a multiply, it breaks apart to add. There's a divide, it breaks apart to subtract. And if there's an exponent, it moves to the front. Does this sound familiar to you? Hopefully, no. Okay, well, let's review the first one. Okay, so the first way you can expand is look at this radical symbol as a 1/2 power. And to expand, I'm not doing a derivative right now. I'm just expanding. I'm just moving the 1/2 in front, and that's totally allowed. That's a rule that you learned back in Math 3. Not a derivative yet, just expanding. But that makes my problem way, way easier, because if I had not expanded that, this would be a chain rule. But now I don't have to do a chain rule because I just got the parenthesis power to the front. So I don't have to do a chain rule. So when I go to do my derivative, f prime of x, I'm going to carry down the 1/2. And then my new value of u is significantly shorter. Now it's just a minus 1. Put your computer up, please. So u prime over u is going to be 1 over a minus 1. And then because it's a base 2, I have to put ln 2 in the bottom. And because of the way I wrote this, I'm going to squeeze it in here at the end. And then these are multiplied together. I carried down the 1/2. I did my u prime over u, ln a. I'm just going to multiply straight across the bottom. So it will look like this. 1 over 2 ln 2 of a minus 1. Or 1 over ln of 4, a minus 1. Anyone have any guesses on how I went from here to here?
Minus.
Okay, close, not quite. All right, so one thought was like multiply the twos together. It's a little, what were you thinking?
2 to the power 3 would be 4.
Perfect. Okay, so it's funny because 2 times 2 is 4, but also 2 squared is 4. So if you go back and then like condense. So a way you can expand is move the power to the front. And you can condense by taking a number in front and making it a power. So then if that was 2 squared, that could turn into 4. So that's the first way we can expand, is with moving the power in front. And then the rule is u prime over u, chain on ln a in the denominator. Okay, everyone hanging in there so far? Yes, question.
Will we ever have?
You'll never end up with the e in the equation because ln of e is 1. Excellent question. If you accidentally put it in there, it wouldn't be wrong. Because ln of e is 1. But you certainly don't have to. I wouldn't, just because it's like an extra thing to put in. Okay, let's try our next one. Okay, so number 3. We are going to expand first. And that's not taking our derivative yet. That's just like making the problem more simplified before I do derivative. That helps me avoid doing chain rule, product rule, push rule. Right now, this would be like a push rule divided by another fraction. So expand. This division changes to a subtraction. That's not taking the derivative yet. That's expanding. So it has to do with exponents. Actually, like when you're, the reason this rule exists, so the question was kind of like about that rule. The reason that rule exists is because when you have exponents like this and you're dividing, you subtract the exponents. This is x to the, oops, equals. This is supposed to be an equal, sorry, equals x to the 6 minus 4. So that's where this comes from, is that if you have a division here, what you're actually doing is subtracting. Logarithms are the opposite of exponents, and so they have the same exponent roots. Perfect, good questions. Yeah, that's right. So if there was a multiply in there, it would split apart into a plus. Yep, good question. And we're wanting to do that because it avoids doing the quotient rule. And you can do quotient rule, you get the same answer we will, but the expanding helps you simplify it first. Okay, so this is ln e, which means I'm not going to have to put the ln a on the bottom because that will just cancel out to 1. So I'm just doing u prime over u. So this will be the easiest derivative. This part is going to go to 1 over x, u prime over u. And then this one is going to go to u prime over u, 1 over x plus 1. And then I'm just going to do a quick little baby common denominator and add them and subtract them together. So this one will be multiplied by x over x. This one times x plus 1 over x plus 1. we'll have x plus 1 from the first fraction minus x from the second fraction. And then on the top, since I'm subtracting there, I can drop the parentheses, x minus x is 0. So I just get 1 over x times x plus 1. Final answer, you do not have to distribute. Okay, questions on that one? I think these are easier than doing like product rule, quotient rule, chain rule, like all that stuff mixed together the last couple of days that we've done, as long as you remember to expand first. If you forget that expand stuff, it gets to be like, these can be tough, but as long as you expand first, these shouldn't be too bad. Okay, number 4 has log base 7. Okay, so this is going to be my a value. So now I'm going to have to put ln a in the bottom. And then this can be expanded. 2 things. So first of all, square root. How's that? Like, how can we expand this? Okay, got a 1/2. Very good. We'll put that as a 1/2 in front. So let's start with that. The 1/2 log x minus 1 over x plus 1. I'm only putting parentheses there so that when I split this again, I can see my whole thing. What's my second expanded? Subtract. Very good. You guys say the same thing, Evan? Okay, so subtract. So this should be 1/2. Now, the 1/2 has to apply to all of it. So I can either put the 1/2 with both, or I'm just gonna do like big parentheses and split it like this. I forgot my a. Sorry, 7. And then that's up to you if you want to put the 1/2 just all the way in the front or with both of them, as long as you are showing somehow that the 1/2 applies to them. That's not derivative yet, that's just standing out. Okay, now let's do derivatives. The 1/2 is a constant multiple, so it just stays with my problem. And I go through and do, this is u, this is u. So I do u prime over u ln a. So I'm going to have 1 over x minus 1 ln 7 in there. And I'm putting the ln 7 in front only because that's the way it's written in our rule on like notes. But it doesn't really matter if it's in the beginning or end. Okay, minus u prime over u again. ln 7. And then I'm doing a common denominator again. However, it's a little bit longer this time. They both have the ln 7, so that makes it feel a little confusing. But this one's just going to be multiplied by the x minus 1. And this one's going to be multiplied by the x plus 1. To get the common denominator of ln 7, x plus 1, x minus 1. But you have to have all the terms in there. I'm trying to get all of those terms multiplied by what's missing. I'm going to get x plus 1 minus x minus 1. And so the x and the minus x will actually cancel out. And then 1 plus negative 1 will be positive 2. Right? 2. Okay, then my 2's can cancel. This 2 on top and 1/2 out front can cancel. And then you can write your answer as the 2 individual factors there, or if you want to shorten it up a bit, you can do x squared minus 1. Yes.
Why do they exist by the logarithm? Like you noted x plus 1 went inside the ln 7 5.
Oh, it's not. Okay, good question. So it's not inside, it's multiplied. ln 7 is a number.
Okay. Oh, okay.
Okay, poor use of parentheses there, I guess on my part. So the question was like, wait, like, There's ln of 7, you were thinking that x minus 1 was part of the logarithm, and it's not. Thank you for asking that, to clarify. And that's true, every time we do these, that ln a in the front is not part of the, like u prime over u, it's just out front, it's not a part of it. Excellent question. Okay, we got one more, that's a trig one. Any questions on this one though? Do you think you have the rule kind of memorized for Friday? A little, we just gotta like not forget it.
Yeah.
Yeah, that's the trick, like not forget it before Friday, especially when you have a day off. Okay, number 5. My base is E. And that part's E. Oh, let's see, do we remember secant? What's the derivative of secant? Of it. Tangent x, secant x, yes. One of each, right? Secant, tangent. Okay, so derivative, very good, is. I usually say it in this order, so I'm going to write it in this order, but you said that perfectly fine. So tangent secant or secant tangent, that's big U prime, divided by U. This is going to be secant on the bottom. I don't have to put ln a this time because of that. And then these cancel and I just get tangent. What do you think? What happened to the work?
Read the secant value.
U prime over U.
Oh, like clearly so.
No. Okay, so not today, but in like 4 months, we're gonna do anti-derivative rules. Anti-derivative rules. And we're gonna say, what's the antiderivative of tangent? And you're gonna say, it's ln secant. Yes, question.
Is that called integration?
It is, yes. Integration, antiderivative. Anyone hear anything else? So you can see. Fundamental theorem of calculus and apply. We have boundaries, yeah. Okay, that's half. That's half of what we're doing today. Any questions on the first half? All right, let's take a look at the second set.
You can't even see.
Okay, second set of derivatives, very similar to the last one, where like when you have a logarithm and there's like an ln e in there, you don't have to write it. Same thing happens here. All right, boys, you with me? Okay, so here's our rule. The rule is actually 3 parts. Both of these rules are 3 parts. So start out with the harder one. Start out with this one. Okay, so a to the u. A is a number. U is a variable. Let me point out, this rule does not apply. So non-examples are like x to the 5th or x to the 1/3. That's the opposite of what I'm talking about. I'm talking about if the number is on the bottom and the variable is on the top. So for example, 5 to the 2x. You see the difference? It'd be very tempting to get these rules fixed up, but this is not the rule we're talking. We did power rule, but now we're saying, oh, but what if the number was on the bottom and x is on the top? What would we do? And that's this. So a to the u has 3 parts. It goes to itself, a to the u. Then times the derivative of the power, and then times ln of a, where a is the base. So 3 parts, a to the u, u prime, ln a. A to the u, u prime, ln a. A to the u, u prime, ln a. E to the u is the same thing. We had already done e to the x, and that was like the simplest version. But what if you had like an x squared up here, or something more complicated than just x? In that case, so start with this. It goes 3 parts again. E to the u, u prime. At the end, there's an ln e, but guess what? We're not going to write it because that comes out to be 1. Ln of the base. Now, I'm just showing you that so you can like find the similarities between these two because you got to memorize them both. And they really are both the same. It's just one has an ln e and one has an ln a. Yes, question.
It's kind of like the double chain.
It is just like the double chain rule. That's right. Very good. Yes, just like double chain rule. So you're like chaining on the derivative of the power and then chaining on a log at the end. Yes. Oh, so we're going to okay. These problems are quick. Okay, so derivatives of each. So start. This is your a to the u because it's a number on the bottom. and a power on the top. But we're in the specific case of e to the u. So e to the u, because it's e on the bottom, it's a little bit shorter. So f prime of x. The derivative goes to a to the u or e to the u. So itself. Then I chain on the derivative of the power. So I'm doing u prime, which is 8x. And then I chain on ln of the base, which in this case is ln e. So I'm not going to write it, and then that's just your answer, 8x. E to the 4x squared minus 6. So here's another one. We've got a number on the bottom. Variable is the power. So this is my u. So I go to take my derivative. It goes to e to the u. So I just copy the same thing down again. Times, I have to do the derivative of the power. And a really quick side note about this power, you do not have to call that a quotient rule. Quotient rule, we only had, like if you had x divided by x, and there's a constant on the top. So I'm going to rewrite it like this instead. And make this be 3 x to the negative 2. And so the u prime is that 3x to the negative 2. So u prime is 3 over x squared. I just want to write that nice and pretty. So it's one fraction. It would look like this. And I'm leaving it like this because that's how we started. But technically, that's a negative power. If you wanted to move that to the bottom. Question answer.
We have.
I would leave it like that because it started with a negative there. But the only other thing you could do to simplify would be to move the e to the bottom.
No. Like that.
Oh, yeah, you can leave it like that. I'm just going to write it pretty. That's fine to leave it like that. Yes.
Excellent.
The x on, wait, say it again, is x on the bottom not part of the derivative? Yes, okay, so in this, when I was doing like the derivative of the power, I did a little like side note of that, yes, so I moved it up. And the reason we didn't have to do quotient rule there is because negative 3 was on top. If that had been a variable, we'd have had to done a whole quotient rule. Excellent questions, you guys. Any others? Okay, all right, let's see, so we're on the next page. Okay, number 3 is another a to the u. And this time my base is a 3, so I've got to do all 3 parts. I can't shortcut it. So my u is 2x. Kind of thinking about that as my side note. So f prime of x goes to a to the u, so just the function itself, times u prime, which is the derivative of the power, and then times ln 3. And then there's like really nothing you can do to combine anything there. It's very, very tempting. Do not do 3 times 2 is 6. Don't do that. Because this one has a power, so I can't multiply it by that 2. This is just answer like that. So this is your a to the u prime, ln a. Yes.
Now, square. Is that when you put something outside?
Oh, good point. Yeah, okay, but you could make this. That's a good question. You could make it ln 9. Yeah, good catch. That's one thing I guess you could do to make it like shorter. We could condense it. Yep, so it's not just if it's on the outside, as long as it's multiplied, you can move that number up as a power. Very good question.
But we need to pull this.
Wait, but the 3, this one right here.
No, that.
Okay, tell me your question again.
Oh. Never mind. Yeah, we leave it like the top.
Yes.
We leave it.
Yeah.
You should be aware that that's an option. It's all like this could be the answer. Okay, number 4. Sorry, now I got this like kind of in that space. Let's see if I can change color. But I didn't even fill that one. Yeah.
Yeah.
It's only right stuff.
It's too big.
Mine's like, oh, because I'm used to using this, I'm sure. Thank
That
you.
means a bright, bright.
I thought I better change color because that was the other problem. Okay. All right, number 4, see if you see what I see. Okay. Do you see a spot? You see it? Yes, I see it. Do you see an A to the U? And you know it's A to the U because 5 is on the bottom and S is on top. So it's like totally different rule. Okay, so I see this is A and this is B. And so I'm going to do my product rule, but as I'm doing my product rule, I've got to do a B prime, which is my new rule today. Look, you got like half you already working ahead. Good job. Okay, so A B prime is going to be copy down the original x squared. That's your A. B prime. Use my shiny new rule. So it goes to A to the U. Copying the original thing down. U prime is the derivative of the power. And then ln of the base, ln A. Okay, plus, then I do A prime B. So the derivative of the first is 2x. And then times 5 to the 4x. Okay, good question. I gave you 2 A's. That's confusing. Okay, so the question's like, what is this ln 5? And that's because on this one right here, I'm using this rule, where there's 3 parts to it, and that ln A is coming from ln of the base of the problem that I started with, not the first term. Paper on. Oh, that's just a blank page? No, what happened to my stuff? There we go. Okay, so this part is like A to the U. Right, this
How
part.
did you know it was A?
Oh, because it was a number on the bottom and a variable for the power.
Okay, so variable.
Yes. Yep, that's right. There's not a whole lot you can do to simplify it besides maybe take it out of GCF. Another question? No, you're doing one. What, so this is like A, B prime,
Oh, wait,
and then A prime.
X-ray.
Okay, all I can do really to think about simplifying is taking out 5 to the 4x.
I can't leave it all. It's my.
And 2x.
I see.
You're messed up person.
You are totally fine to put a box around that answer and be like, done. But because it's multiple choice, let's talk about GCM question.
My eyes.
Because this has a 2x, this has a 4 and an x squared.
I wouldn't have these. Oh.
So we take out like one of those x's, and then the 2 from the 2. If you would rather look at like this could be thought of as 4x squared,
Okay, gotcha.
if that's helpful.
Yeah, that's.
Like it's kind of like the plus sign is what divides. Voice. The plus sign right here divides this into 2 big terms, and within that term, all of these things are multiplied together. And so like you can multiply pieces together if you want, as long as you're allowed to. You can't do 4 times 5 there, but you could do the 4 times the x. Because this has a power, so you couldn't multiply by that. You're welcome. Okay, so this goes out front. A 2 from there goes out front, an x from there goes out front, and then I've got ln 5 left. And then there, everything goes out front. You don't have to do GCM and open-ended questions. I'm just showing this to you, like if you have any multiple choice questions and you do your derivative and you're like, oh, it doesn't look like any of the answers. That's something you could do to GCF. You could also bring that 2 up and make it a 25 question. Question on it. Okay, because in this term, I took the 2x out front and then the 5 to the 4x out front. And since they were both out front, I just put a 1 in there as a placeholder so that that whole term didn't disappear. Okay, take a look at number 5 with me. Do you guys see number 5? Do you see a change? Yes, okay. I think so too. Excellent, yeah, parentheses to a power, good. Okay, so number 5 has parentheses to a power. Good job. All right, I also see a to the u in there. Okay, then let me ask you, like, how do I know a to the u? Like, how do I know a to the u is in there? 7 to the power of x. Yes, okay, the number's on the bottom, the x is on the top. So like when it's the number on the bottom, x on the top, that's our shiny new rule for today. All right, so we start out with chain rule is I bring the 3 to the front, leave the parentheses alone. Subtract 1 from the power. Then I have to chain on the derivative of the inside of the parentheses. All right, so I'm doing the derivative of this, and that's where my new rule comes in because that's an a to the u. So see if you can kind of do this one in your head. I'm gonna go really slow. See if you can think of it yourself. So it's a to the u is 7 to the x. U prime is 1. ln A is ln 7. You have it? Yeah, remember it? So we're trying to remember these, so we like remember them to Friday. You're gonna be stopping tomorrow to remind yourself. And again, there's really nothing you can do to simplify there. Besides not write the 1 maybe, or you could move those to the front. I'm not going to. I'm just gonna call it.
What did you find?
1. So this right here is my A, and that's my U. Okay, last point thing up here is just, this kind of hits on yesterday's worksheet that you picked up, like the no function given worksheet, is where like to find a derivative of something that doesn't actually have the equation in there, you just got to pick which rule you're using. This is a composition, it's not a product rule. So this derivative would be h prime of x. So we do the derivative of the outside function would be f prime. I'll leave the inside function alone. And then chain on the derivative of the inside function. And you are doing a derivative, it's just the equation's like not written there. So you're following the rule, which is chain rule, this derivative of the outside function. Leave the parentheses alone, then chain on the derivative of the inside.
Whenever you have.
Yes, perfect. I could have said that anybody. Yes, exactly. Yeah. Yeah. Very good. Okay, so number 2. Also, not a product rule. That's a chain. This is a double chain rule. Did you guys get to watch the Paco Taco video? You did. I think my first period, like when we went to watch it, that was like exactly when the internet went out. I haven't shown them yet. Okay, so G prime, that's the derivative of the outside. Leave the inside alone. Chain on the derivative of the inside, so that'll become F prime. And then there's another set of parentheses, so double chain rule times 3. Because of the other parentheses there. I don't think that worksheet has any double chain rule, but I can't still deep breath. We did it. Yes, question. Correct. This is exactly right. Yes, so the first question says a 1 at the end. Yeah. Right. Yes, yes. Okay, so that's like 4 or 5 more rules. That's on the quiz Friday, so we gotta just make sure you practice together tomorrow or tonight or both. All right, we're gonna do FRQs next. Yes, Okay, so quick 30-second break, I'm gonna go grab, some FRQs and markers. Oh.
So, look at that work. That was the, I think that was the.
That's why.